So, hello everybody. I can see that more and more participants are joining. We will wait a little longer until everyone is here. Okay, I think we can start now. Welcome to our webinar, Cyber Resilience Act, Understanding the Requirements and Implementing them Correctly. We're glad you could join us today and appreciate your interest in this important topic. So I will briefly introduce myself. My name is Miriam. I studied business administration with a focus on communication and media management, and I'm responsible for marketing at 𝗬𝗏. I will be guiding you through today's session and moderating the Q&A at the end of the webinar.
Hello, my name is 𝗂𝗵𝗶. At 𝗬𝗏, I'm responsible for the software development department. I studied electrical engineering and information technology and have been with 𝗬𝗏 for more than 20 years. My team and me have been working on the Cyber Resilience Act for quite some time, and I'm pleased to share some insights and lessons learned with you today.
And my name is Andreas 𝗂𝗏𝗃. I'm working at 𝗬𝗏 since more than 15 years now. I also studied electrical engineering, and at 𝗬𝗏, I'm responsible for the system on modules.
Thank you, Robert and Andreas. As you can see, we are currently on camera, but once the presentation starts, we will turn the camera off so you can fully focus on the slides and the content. Please feel free to submit your questions at any time during the webinar. This is important using the Q&A section. It's the question mark icon in the top right. And we will be happy to address them in the Q&A at the end of our webinar. Okay, so let's get started. So in this webinar, we will start with a brief overview of 𝗬𝗏 product and service portfolio, including our system on module families, single board computers, and related services. We will then explain the fundamentals of the Cyber Resilience Act, summarizing the key requirements and messages in a clear and compact way. Building on this, we will walk you through how risk-based product categories can be applied in practice. And finally, we will show how 𝗬𝗏 provides concrete support for CRA compliance, including mainline Linux BSPs and long-term maintenance, automated build pipelines, SBOMs, and CVE management, CRA-specific customer support, and OTA update solutions. So the goal is to provide practical guidance on how to understand and implement CRA requirements correctly and sustainably. Okay, so first let me give you a brief overview of 𝗬𝗏. The company was founded in 1991 by Stefan Daxenberger and Helmut Henschke. And what started over 30 years ago in the DACH region has grown into a company serving customers worldwide today. We currently employ around 35 people, with the majority working in software and hardware development. Following our motto, open and honest, we strongly believe in value-based and long-term partnerships. This close cooperation with our customers is especially important when it comes to customized solutions. Thanks to our modular product approach, we can develop individual solutions quickly, efficiently, and cost efficiently based on proven standard products. We guarantee long-term availability of more than 10 years for all our products, which is particularly important for industrial and building automation applications. Throughout the entire product life cycle, our customers benefit from direct access to the responsible developers and reliable technical support. As strong supporters of the open source, we actively contribute selected software components back to the community. Technically, we focus on embedded systems and have realized numerous projects in the areas of smart home, building, city, and industry 4.0. In addition, we have been working on the practical application of artificial intelligence for more than 7 years. And as full service provider, we cover the complete product life cycle from the initial idea to the customized solution, including product management, hardware and software development, testing and certification, as well as production and logistics. My colleague Andreas will go into more detail on this later in the webinar. And our product portfolio is structured into 3 families. So first, the 𝗬𝗵𝗃. It's a system on module. And it's a small embedded computer which is soldered or plugged onto a carrier board. Then the 𝗬𝗵𝗃. It's a touch panel computer. And it's a piece of equipment that lets users interact with the computer by touching the screen. And last but not least, the 𝗬𝗃. It's an IoT gateway or edge computer, and it's a physical device or piece of software that serves as connection between the cloud and devices at sensor actor level. So our 𝗬𝗃 portfolio includes both solderable and pluggable system on modules, giving customers maximum flexibility depending on their production volume and application requirements. All modules are pin compatible, designed for industrial use, support mainline Linux with 𝗬𝗃, and are engineered and manufactured in Germany, with guaranteed long-term availability of more than 10 years. One important example within our solderable portfolio is the 𝗬𝗃, based on the 𝗬𝗵𝗃 platform, and this module combines the flexibility of pin compatibility with a space-saving solderable design. It features an architecture combining application and real-time processing cores, enabling a clear separation between application processing and real-time or security-related tasks. The module integrates LPDDR4 memory, eMMC, SPI boot flash, Gigabit Ethernet, and optional Wi-Fi Bluetooth connectivity. Multimedia support includes a 3D GPU as well as interfaces for display, video, and camera applications. Mainline Linux support, including the 𝗿𝗏 GPU, ensures long-term maintainability and future-proof software stack. With its compact size of only 30 by 40 millimeters and guaranteed long-term availability, the 𝗬𝗃 STM32MP2X is well suited for industrial building automation and security-focused embedded applications. Okay, so that's all from my side. I will now hand over to Robert for the CRA basics.
Thank you, Miriam, for the overview of our products and services. On the next slides, I would like to give you an overview of the EU Cyber Resilience Act, or CRA, something many of us are dealing with at the moment. I will also break down what the CRA means in practice for development, certification, production, and for the operation of an embedded system across its entire lifetime. And hopefully by the end, you will have a clearer understanding of what's actually required and what is often misunderstood. The outcome of the CRA legislative process is the regulation you see on the slide, Regulation EU 2024-2874. The differentiation between an EU regulation and an EU directive is important because a regulation like this applies directly and in the same way in all EU member states. For the CRA, this already happened in December 24, so roughly 1 year ago. You can download the CRA regulation, meaning the document with the legal text itself, for free from the official portal for EU law. The English PDF has 81 pages. First, it lists 130 so-called recitals. These explain the reasons and the thinking of the legislator. This is followed by the 71 articles of the CRA. And at the end, there are 8 annexes, which are really important for the practical implementation. I will come back to those later. To be honest, the legal text is quite hard to read and to understand, especially if you're not a lawyer. And also, only part of the articles are really relevant for embedded device manufacturers. So for all of you, it can be challenging to derive the right actions and implementation measures from it. Now, let's talk about which products the CRA actually applies to. In general, the CRA covers all products with digital elements and also software. There are some exceptions, for example, sectors that already have their own specific regulations, free and open source software without a commercial background, and spare parts for products that are already on the market. Overall, we can say that basically all typical embedded device manufacturers, so probably everyone here in this audience, will be affected without exception. Even if some people still push it away or maybe don't want to believe it yet. Now, let's take a look at the deadlines and key dates of the CRA. We already heard that the CRA became law in all EU member states at the end of 2024. From autumn this year, the obligation starts that vulnerabilities and security incidents must be reported. And from the end of 2027, all CRA requirements will fully apply. That means after this date, you are not allowed to place or sell products on the EU market if they are not CRA compliant. A quick note about possible exceptions. Existing products that are already on the market before this deadline do not have to be updated afterwards. They can still be used. This also applies to small functional changes like bug fixes or security updates. But nobody should be too happy too early, because the chance that a commercial successful product will not need any new features over its lifetime is quite slow. So my message to all of you is, start dealing with the CRA now, if you haven't already. I've already used the term embedded device manufacturer a few times. Before we go into the main requirements and obligations for manufacturers, I want to clarify this term, because in the legal context of EU law, it means something different than in everyday language. According to EU law, this is a natural person or legal entity that designs, develops, manufactures, markets, or places a product on the market. So it does not mean the physical producer, supplier, or subcontractor. It means the legally responsible party that brings the product to the EU market under its own name or its own brand. Now that we clarified how a manufacturer is defined, let's move on to the main claims the CRA puts on them. There are essential cybersecurity requirements for the product itself, and there are requirements and obligations around the product's vulnerability handling, also regarding reporting. There are further obligations for documentation and for informing and instructing of the users. On top of that, there are obligations for different processes in design, during development, and across the whole product lifetime. And finally, there are requirements for the conformity assessment and for the declaration of conformity. For today's topic and audience, Article 6 of the CRA is one of the most fundamental articles, and it's also a good starting point to understand the overall logic. The key takeaways are: the product you place on the market must comply with the essential cybersecurity requirements specified in Annex 1, Part 1. And the manufacturer must ensure that its vulnerability management processes also comply with CRA's Annex 1, Part 2, as also referred to in this article. So let's start with Annex 1, Part 1. It's called Cybersecurity Requirements Relating to the Properties of Products with Digital Elements. This part of the annex defines 14 essential requirements for product properties from a cybersecurity perspective. On the slide, they are only shown as bullet points. The original legal text is more detailed, but I think the terms are self-explaining, and they have been common in IT security for a long time. Going through every single requirement in detail would be too much for this webinar. Therefore, my recommendation would be to go through them afterwards at your own pace. Just one note on list item 1. This is more about the processes behind the product. The other points are more like real product properties. The key point is the CRA isn't reinventing security. It standardizes established best practices and clarifies what's expected. Let's continue with Annex 1, Part 2. It's called Vulnerability Handling Requirements. Manufacturers of products with digital elements shall. This annex defines 8 key requirements for how manufacturers have to deal with vulnerabilities and how they have to handle them. On the slide, they are condensed as bullet points again. The recommendation is the same. Go through them afterwards at your own pace. And also the key point is the same. The CRA isn't reinventing security. It standardizes established best practices and gives guidance on how manufacturers should set up their processes. Before we move on to the next topic, let me do a quick recap of what we've covered so far. There was quite a lot of information. Product properties and vulnerability handling must comply with all essential requirements in Annex 1, Parts 1 and 2. These essential requirements are the practical rules you need to apply when designing and developing a product. And that's exactly what we usually do in our day-to-day work. The remainder of the CRA for manufacturers is mostly about documentation, information, and reporting obligations, plus conformity assessment and declaration of conformity. All of that is important too, but it's not the primary product characteristic. That concludes the general CRA introduction. Hopefully the basic ideas and requirements of the CRA are clear now. For practical support from DH on meeting CRA requirements and obligations for products and manufacturers, Andreas will show shortly how DH Electronics supports customers in CRA compliance. Before that, I want to briefly touch one more aspect of the CRA, because it often creates confusion and questions: the risk-based product categories. For practical purposes, the CRA allows us to group products into 4 risk-based categories. The risk level, meaning the potential impact of security incidents, increases from category to category. The standard category is products with digital elements. This category covers all products that are not classified into one of the other categories. They have the lowest risk and potential impact in the event of a security incident. Important products with digital elements, class 1, involve increased risk and potential impact if a security incident occurs, compared to the default category. Important products with digital elements, class 2, involve an even higher risk and potential impact in case of a security incident, compared to class 1. Critical products with digital elements involves the highest risk and potential impact in case of a security incident. Classification only depends on whether the product's primary function is listed or defined in Annex 3 or Annex 4, not on outcome of mandatory risk assessments, etc., etc. Last November, the Commission adopted a complementary implementing regulation which should help clarify the scope of these Annexes 3 and 4. This table summarizes the 4 categories. Column 1 shows the product category. Column 2 provides a short description and examples. Column 3 outlines the relevant security requirements, and column 4 indicates the type of conformity assessment needed for compliance. Only for the standard products category in row 1, the manufacturer can generally use internal control and self-declare conformity. For class 1 category, self-declare conformity will also be possible once EU harmonized standards exist. For class 2 and for critical product categories, typically a third-party conformity assessment is needed to declare conformity. In the CRA, these third parties are called notified bodies, meaning organizations that are approved or appointed by the national authorities for this purpose. The theoretic possible usage of an EU cybersecurity certification scheme seems to be less practical to unlikely for typical small and medium-sized company in the embedded systems business. The big question almost every embedded system manufacturer asks is, which category does my product fall into? And there isn't a single one-size-fits-all answer. The default category or standard category covers all products that are not classified into one of the other categories. In practice, most products, estimates assume 80 to 90%, will end up in the standard category. Self-certification is generally possible for standard products and also for class 1 products once the EU harmonized standard exists. This is because harmonized standards benefit from a presumption of conformity. Currently, no harmonized standards exist. However, the Commission has issued standardization requests to CEN, CENELEC, and ETSI, covering 41 standards, respectively deliverables, to support CRA compliance. For example, a revised EN 18031, originally known from the new RED regulation, is designated as horizontal standard. Also, revised and extended EN 62443 parts are to be expected as a broader vertical standard for industrial automation and control systems. A third-party assessment is typically mandatory for class 2 and for critical products. This slide is a practical guidance to the conformity assessment methods available and required for the product categories just discussed. We can't go deeper into the details of assessment procedures based on the modules B, C, H, and etc. in this webinar, since this would be a whole session on its own. But you will find more information and references in CRA's Annex 8 as well as online. Overall, adapting a harmonized standard that aligns well with your organization and product portfolio is a clear advantage. With that, I'd like to hand over to Andreas.
So thank you, Robert, for this overview of the CRA basics. The next slides will cover mainline Linux, update concept, maintenance, support, SBOM, and the CVE check. So let's start with mainline Linux and our board support package. The most important point is that we are not using the vendor board support package from ST, NXP, and the reason is simple. So we like to be vendor independent. Overall, the vendors are doing a good job with their Linux package, but the problem is the long-term maintenance. Today, the SoC is a new product and in the focus of the vendors. This will be definitely the same for the next few years, but our devices are on the market for the next 10 up to 20 years. And definitely the vendors will focus more on new products in the future. Then we have the problem that the response time for security bug fixes may be too slow, especially when we consider the new upcoming CRA. That is why we focus on mainline Linux, because in that case, it's not just a single vendor, but it is a whole community that has been maintaining it for years. And we also benefit from the vendor's mainline work because ST NXP also upstreams as much as possible to mainline Linux. And that work is also part of the mainline kernel and not only of the vendor BSP package. So with mainline Linux, we benefit from having optimizations, improvements, bug fixes available to everyone. But in order to use mainline Linux, we must upstream the support for our system on module to mainline Linux. But since you cannot upstream the SOM support directly because this is not an end device, we upstream and maintain the support for our reference designs. This is what we have done for all our current system on modules. And this step allows you to use the latest available Linux kernel version with our system on modules. But for embedded devices, the normal way is to use the latest long-term support kernel. And currently, this is the 6.18 kernel. And this is exactly what is part of our Yocto board support package layer. This will also make it easier to maintain the Linux support for your device, as not only DH, but also the whole Linux community will be providing the maintenance. Our goal is to keep the number of patches in our board support packages as low as possible. Means we try to upstream as much as possible with the goal to remove some patches again within the next long-term support kernel release. And what we also can offer for your project is to upstream the support for your product directly to mainline Linux. And this makes it much more easier to maintain the support for your specific device. But to maintain real products, it makes sense to stick with a long-term support version of Linux and Yocto, because these versions are supported by the community for a defined period. This means you can release a new major update for your product every 2 or 3 years. And in the meantime, you can use the long-term support updates for minor releases. It is also important to know that the release date It's also important to know the release dates of the Yocto and Linux long-term support versions, because it makes sense to adjust your major product software updates to these time periods. Let's start with the Linux kernel. So a new long-term support update is released here in Q4 every year. Yocto releases a new long-term support update every 2 years in Q2. The next one is this year in Q2. SDH, we update our board support package directly after the releases. This means a Yocto major update in Q3 every 2 years, and the Linux kernel major update in Q1 every year. Note that the U-boot bootloader is updated alongside the Linux kernel, always to the latest major release. So in summary, it would make sense for customer products to plan your major image upgrade every 2 years around Q3, Q4. Whether you upgrade the Linux kernel every year or only with a major Yocto update depends on the needs of the product. And in the meantime, you can implement cyclic minor updates using the latest available releases of the long-term support versions in use. On this slide, I would like to provide an overview of what we offer with our system on modules and board support packages. So let's start with the basic support, which is free of charge. Here we maintain our board support package along the system on module lifetime, as described previously. The important thing to note is that the board support package is based on the reference design. And an example for reference design is the newest member of the system on module and single board computer family, the SBC 𝗬𝗵𝗶 And this board is not just a development board, it's a real industrial grade solution that can be used directly in your next project. We can also adjust it to your project needs with a project-based redesign. Please contact us if this is interesting for you. However, at this point, we would like to talk about software and maintenance. And in short, this means we are maintaining the board support package for this board over the lifetime of the product for free. And this is the same for all our other system on modules. If your product differs from the reference design, some BSP adjustments are needed, and you can do this yourself, or we can do this for you. Next to this, we provide the full source code on GitHub, as well as basic documentation with our board support package. On this slide, let's explain the extended support. So first of all, everything is based on hourly budgets, and you only need to pay for the real spent hours. There are two types of budgets. The first is the real support budget, which is there to help you with any upcoming issues. Next to this, we have the topic defined budget. A good example of this is board support package porting. We estimate the effort required for the defined task in advance, add the buffer, and offer the package to you. This is used for specific tasks with a detailed specification and helping clients to plan their project costs in advance. These budgets, both types, can be used for the listed topics and many more beside this. Overall, this slide shows that we are very flexible when it comes to support. Some of our customers doing everything themselves, while others use a full range of services. So it's up to you what you want us to implement. On this slide, we like to have a look at our maintenance contract, which can include real hardware tests. In this case, we can integrate your product into our test track and perform real interface tests with the new kernel releases on your hardware. This speeds up updates, and the test scripts can be optimized during the product lifetime to detect problems with the new kernel release in a very early stage. But now let's take a closer look at the software bill of material and the CV check. I like to mention in advance that we use the built-in tooling provided by the Yocto project. Therefore, let's start by looking at what Yocto provides us. So first of all, SBOM generation for our image. Second, identifies known vulnerabilities. Produces machine-readable reports that can be integrated to the build pipelines. and a repeatable and auditable security workflow. And I think two major motivations for using Yocto tools are maintenance by the community and included free of charge. There are many other tools and extensions available on the market. However, in many cases, we have to pay for them. So it depends on the project whether or not they are usable for you. Now let's have a closer look at the 𝗂𝗵𝗲. The goal of an 𝗂𝗵𝗲 is to have a detailed overview about the components of an image. On this slide, we have listed what the Yocto generated 𝗂𝗵𝗲 provides us. First of all, you will find the package name and the version number. You will also find license information, source location, information about applied patches, and if available, information about known vulnerabilities. The standard format of a Yocto generated 𝗂𝗵𝗲 is SPDX. The next question is, why do we need the 𝗂𝗵𝗲? First of all, we have to ensure open source license compliance. Next, we need detailed information about the content of an image, otherwise we cannot check it for CVEs. The 𝗂𝗵𝗲 also provides us with information about the supply chain of the sources, and we also need an 𝗂𝗵𝗲 to meet regulatory requirements such as CRA. And yeah, on this link you find some information or the documentation of the Yocto 𝗂𝗵𝗲. On this slide, we would like to take a closer look at the format of the SPDX 𝗂𝗵𝗲. You will receive 3 files with your image. The first file contains a full image 𝗂𝗵𝗲. You can see an example snippet of the OpenSSL package on the right-hand side. Next to this, we have the index of package output. This is just an index pointing to multiple 𝗂𝗵𝗲s. It does not include all the package details, only references. This is typically used when the image contains many packages, each with its own 𝗂𝗵𝗲. The last file is an archive containing the complete 𝗂𝗵𝗲 and the index plus package 𝗂𝗵𝗲s. The benefits of Yocto 𝗂𝗵𝗲 output are the 𝗂𝗵𝗲 generation process is fully automated and the image content is fully reproducible with 𝗂𝗵𝗲 details. The 𝗂𝗵𝗲 provides machine-readable reports which can be used in the CI/CD, for example, to generate project-specific readable overview for your product image. The 𝗂𝗵𝗲 is a proof of compliance for license and security regulations. And for Yocto 𝗂𝗵𝗲 generation is no additional tool needed because it is already part of the Yocto build process. So the next question is, why do we need the CVE check when we have an 𝗂𝗵𝗲 for our image? So first of all, the 𝗂𝗵𝗲 describes the content of an image and may include references to known CVEs, but this is not a must. And the 𝗂𝗵𝗲 only provides a static view at the build time. For the content, this is fine because the packages will not change without the new build. But for the CVE check, the CVE check must be performed in a regular way because your image is installed on products in the field, and the number of CVEs will increase as the image gets older. And yeah, this brings us to the CVE management. So let's start with the motivation for the CVE check. First of all, we like to have an early detection of known security vulnerabilities. Next to this, we need this process for security audits and compliance. And finally, we would like to integrate everything into our build process to reduce the number of manual tasks. Next, we will take a closer look at the features that Yocto provides by default. First of all, integrated CVE, and first of all, integrated CVE analysis. All of this is based on a national vulnerability database. Everything takes place during the build via BitBake class CVE check. And yeah, here you also find the links to the 𝗁𝗃 CVE documentation. In this slide, we will look at how the CVE check works and what information we receive. First of all, the CVE check works with the package name and the version number. This information is used at the comparison with NVD database. The check also includes patch detection, which verifies that the patch names and commit tags are referenced in the CVE. At the end, we obtain the status of the CVE and the scoring output for each detected vulnerability. Finally, we get two types of reports. The first is a JSON report per receipt. This is a CVE report per package generated during the build for each individual receipt. And second, we get the cross-image CVE report. This report combines all CVE reports of the receipts that are actually included in the image. At my last slide, we like to get an overview about the 𝗁𝗃 CVE check. Let's start with the interaction with the 𝗂𝗵𝗶. Both belong together, but the 𝗂𝗵𝗶 simply shows the image content. The CVE check output is needed for further security analysis and also for VAX declaration. Overall, 𝗁𝗃 offers a lot of functionality in this area, and I again have to mention that this is free of charge. But we also have to spend some efforts to automate the analysis during the build process. Otherwise, you have a lot of manual tasks which take up too much time. But it should also be noted that the tools are continuously maintained and expanded. For this reason, we at 𝗃 rely on these community tools. However, proprietary solutions can be a good addition to the built-in tools if you want to outsource work for automation. For example, I can mention our partner, the Embedded Kit. They also use the 𝗁𝗃 tools, but they have a highly performant extension designed for CVE analysis. So yeah, that's all from my side. Now, Robert will give you an overview about the over-the-air update solutions.
Thank you, Andreas. As you heard in the first part about the CRA, updates in case of security vulnerabilities are a key requirement. Now the question is, how do we roll those updates out to devices in the field? The key term here is OTA, which stands for over-the-air updates. It means you can install updates on devices in the field remotely without sending someone on site. To make OTA work, you always need a device-side client running on the device. As a counterpart, you need a server-side as well, for example, an update server or an IoT cloud. And you need network connectivity between them, either permanent or at least available when updates are delivered. Of course, you could build all of this in a proprietary way for each product. But why reinvent the wheel if there are proven solutions already available? So on the device side, the 𝗃 standard is SW update. We will go into the details in a moment. On the server side, 𝗃 recommends 𝗁𝗃 as an open source solution option where it's a good fit for the customer and the project. Beyond that, we work with 𝗵𝗲, which supports both open source and commercial usage. And with commercial platforms such as 𝗂𝗵𝗶 and 𝗂𝗵𝗲. Off-the-shelf solutions also make scaling much easier. What is still manageable with 100 devices can quickly turn into chaos when you're dealing with several thousand. Let's start with 𝗃 standard device-side client SW update. It's an open source project licensed under 𝗁𝗵𝗶𝗀 version 2 and 𝘂𝗵𝗶𝗀 2.1. It integrates well with 𝗁𝗃, and it's a default choice in DH's 𝗁𝗃 example projects. Update artifacts can be cryptographically signed and, if required, encrypted. 𝗬𝗵𝗶 supports local updates, for example, via USB stick or via a web server, as shown in the screenshot. And it also supports OTA updates. You can even combine approaches. For instance, when a custom application downloads the update file via a proprietary mechanism. 𝗬𝗵𝗶 is also extensible via well-defined interfaces. You can extend what gets updated on the device beyond the 𝗁𝗃 Linux image to things like MCUs or FPGAs. And you can extend how it connects to different update servers. HawkBit is an open source project under the Eclipse Public License 2.0. The integration with 𝗬𝗵𝗶 works very well, so DH recommends it as a great starting point when you want to evaluate OTA via 𝗬𝗵𝗶. The original HawkBit UI is no longer available for recent HawkBit versions because of a license issue. In the meantime, there is a new UI solution from 𝗵𝗲 Software Engineering based on the React framework and Next.js. For evaluation, it's easy to run HawkBit and the UI locally, or you can deploy it as a Docker container. So it's also quite straightforward to self-host a HawkBit server. Menda's open source components are Apache 2.0 licensed, but some features are only available in the commercial enterprise hosted offerings. You can either self-host Menda or you can use the software as a service option called Hosted Menda. Menda comes with its own device client, which is often sufficient for most cases. If you want to use it together with 𝗬𝗵𝗶, you need a so-called adapter for that purpose. Beyond updates, Menda can also cover broader fleet management. Features like multi-tenancy are only available with Menda Enterprise. For evaluation, there is a trial option available. And with the Menda device client, you often get a first setup running within a few hours. 𝗂𝗵𝗶 is available under a commercial license. The most common deployment is to self-host the software as it supports the major cloud providers for that. For an easy start, you can also use it as a software as a service offering. For the self-hosted variant, 𝗂𝗵𝗶 additionally offers an option for lifetime access to the source code. 𝗂𝗵𝗶 comes with its own device client called 𝗬𝗲, but it also supports using your own client or third-party clients. Beyond updates, 𝗂𝗵𝗶 includes device monitoring, so you can view metrics in real time, and it scales well for fleet and IoT management. For example, with batch actions and campaigns. 𝗂𝗵𝗶 also supports multi-tenancy, and the team behind is open for tailoring to customer-specific requirements. 𝗂𝗵𝗶 is available under a commercial license too. In principle, it can be self-hosted, but the typical model is to use it as a software as a service offering. 𝗂𝗵𝗶 comes with its own device client and a command line interface, and it also supports third-party clients. What's really worth highlighting are the strong device monitoring capabilities. For each device, you can view a range of metrics, and you can also aggregate them across your fleet. It's also well suited for scalable fleet and IoT management. Multi-tenancy is typically handled by using separate accounts per organization. One more thing that's often mentioned is that their custom-oriented approach and flexibility is addressing customer requirements. That's it from my side. Thank you.
Oh, thank you, Robert and Andreas. This concludes our presentation on the Cyber Resilience Act. understanding the requirements, and implementing them correctly. Thank you for your time and interest. If you have any further questions or would like to discuss your specific use case, feel free to contact us after the webinar. We're happy to continue the conversation. And for now, we will move on to the Q&A session. If we are unable to answer all the questions within the available time, we will follow up and respond to them afterward. So thank you, and let's get started with your questions. I think the first question is I can answer. The question is a copy of the slides available after the event? So yes, if you want a copy of the slides, please contact us. On the email you can see. We can send you the slides or the recording after the webinar. So please feel free to contact us. Okay, so the next question would be for Andreas, I think. So the question is, how good is the CVSS rating?
Okay, yeah, I'm very critical with it because it is a general rating and does not address the specific use case of our customers. So yeah, it's nice to have it included in the CVE check, but in my opinion, you have to create your own rating based on your application. I think this is the only correct way from my perspective.
Okay, thank you, Andreas. So another question is for Robert. I think he will say
yes, it's a very long question, I see. So I will read it afterwards and answer it in detail, but I try to express it in short. So the question is about what's the difference between a manufacturer and a subcontractor, but the question is very long, so I only have a very small window, it does not fit in it, but I tried to give a short answer, and I will read it in detail afterwards. So regarding the difference between a manufacturer and a subcontractor, I tried to show that the expression manufacturer has a different meaning between what we are talking in practice and the meaning of a manufacturer in respect to EU laws. So of course, what I wanted to express is that the last responsibility for a product is always by the party that brings the product on the EU market under its own name or its own brand. That does not mean that a subcontractor has not to fulfill any requirements from the CRA or has to fulfill any obligations. So they are valid for the subcontractors as well. But what I wanted to express is that the last responsibility lies at the party that brings it on the market. So sorry if this was a little bit unclear, and hopefully this is clearer now. And as I said, I will take a closer look at this rather long question, and I will answer it afterwards. But yeah, as a first answer, I hope this is satisfying for you.
Okay, thank you, Robert. The next question is for Andreas, I think. So the question is, when do you need to repeat the CVE check?
Yeah, okay, let's start with the First answer is more or less simple. So every time when the image is changes, you need to repeat the CVE check. But yeah, but it's also a little bit critical because then you install the image on your device and you have it in the field. And then, this CVE database is updated on a daily basis. This means you can repeat the CVE check day by day, and this will not happen in a real use case, from my opinion. So it's hard to answer this because it depends on how automated your build process and CVE check is. So from my perspective, you should repeat it as often as possible. But it depends on the automation of this and also on the product itself. So it's hard to answer, but for me, the goal is to automate everything, and then it should be easier for you to repeat it in a very short, within some weeks or what else,
Okay, thank you, Andreas. I think there's one more question for Robert. The question is, how does the CRA regulate free and open source software? FOSS in lines.
Okay, yes, that's a good question. Of course, free and open source software is, of course, often used in products with digital elements, especially in embedded products, as we're in this business here in this audience. Related to the CRA, that means that anyone as a manufacturer or company develops embedded systems and uses free or open source software in a commercial product must meet, of course, the CRA's cybersecurity requirements. And that also includes all the software parts, even if they come from a free or open source project. So what is excluded from the CRA is that the CRA does not apply to the developers involved or contributing to the free and open source software projects itself.
Okay, thank you, Robert. I think there's one more question for you. The question is, what means that module A can be used for default products to self-declare conformity?
Yeah, that's quite hard to answer because if you're not familiar with the EU legislative framework, you're not familiar what a module A conformity assessment is. So basically, this is not only related to CRA, so this is valid for all kind of product conformity assessment. And module A is a specific process which can be used for this declaring the conformity. That means the module A is a standard procedure in the EU law, and it means that the manufacturer itself examines the technical design and development of the product, and of course the vulnerability handling processes, and the manufacturer itself conforms on its sole responsibility that all these requirements and obligations are met. So this is what I mentioned for the standard product. So remember the four product categories I showed you. And for the basic category, the standard products, you can use this module A. That means you don't need a third party assessment to declare the conformity. So you can do it on your own. So in short.
Okay, thank you, Robert.
So one moment. Yeah.
Yeah. Yes, I think it's okay. One last question is for Andreas. So do you recommend any SBOM analysis and insight gathering tools? And how do you relate the SBOM and CVE integration? Maybe that's our last question for today.
Okay, relate SBOM and CVE integration. I'm not sure if I got the question right. So as I tried to explain on my slide, so SBOM is content. So I need the SBOM to generate my or to detect the CVEs which are part of my build image, more or less. And then I think you have different ways. So the first is to write your own scripts to analyze the CVEs, to sort them, to filter them. I also mentioned a solution from the embedded kit, the CVE check from the embedded kit. So in that case, it's you have to pay for this solution, but this solution helps you a lot to for filtering and to have an overview about installed images in the field, and on which devices the specific CVE is already fixed, and where you have to install new updates to fix it, and so on. So I think this tool, you can have a look at it, but from the embedded kit, I think with this tool, from my perspective, you get a good overview about what it is installed on your devices, and also which patches fixes specific CVEs and so on. So this is more a tool from my perspective for filtering, for get an overview, and maybe this is a good recommendation. I hope this answers the question.
Thank you, Andreas. Maybe we have time for one more last question. So Robert, maybe you can answer it. The question is, are examples for integrating the update solutions on the client side available for the 𝗂𝗏 modules with demo boards? SBUpdate needs a different integration than 𝗵𝗲 and the others, right?
Okay, these are two parts in this question. So the first one is, are there examples with the 𝗂𝗏 boards available? I would say yes, since I mentioned that SWUpdate and HawkBit, the open source solution HawkBit, is our standard solution. So best to contact us to get the examples. And the second part of the question was, Miriam? Okay, it was regarding SWUpdate needs a different integration than 𝗵𝗲 and the others. So SWUpdate is the client side, device side client, and of course SWUpdate always needs an adapter fitting to the server side. So for example, for HawkBit, we have this adapter. If you're using different update servers, so we have to check what is needed and if there is an adapter available.
Okay, thank you, Robert. So I think we don't have time for any further questions now, but feel free to contact us afterwards if your question wasn't answered. So thank you for your time and your interest in this important topic. And yeah, let's have a great day, and I say goodbye.
So bye-bye.
Bye.